Okay, let's start solving this homework. And again, this homework, the main takeaway from it is to really follow the recipe for determining the MER targets and the pinch points. And even though the algebraic method or building the cascade diagram can be tedious at times, however, it's extremely important to practice this to learn how to get these numbers, because the next step will be to build the heat exchange network, which is coming next week. And you cannot build the heat exchange network until you have these specifications or these parameters, basically. So just go through this exercise, please, and it's repetitive, but it's important to practice it so that you don't make you don't just drop some steps or you make mistakes without noticing. Okay, so let's go through them. Let's try to solve these problems here. So for problem number one, given the following streams, H1, H2, C1, C2, temperatures in, temperatures out. You're given heat capacity here, or heat capacity flow rate, and you want to find the MER targets and the pinch points. So let's go to the blackboard here and let's do it step by step and see what we're gonna get. Okay, so I have problem number one. Problem one here, and in this case I'm given four streams, so I'm given each one let's rewrite this properly. Okay, so I have stream, I have the T source in degrees Celsius, I have the T target in degrees Celsius as well, and I have my C, which is in kilowatts per degree Celsius. And let's just write this. I have stream H1, stream H2, stream C1, and stream C2 for this problem. Okay, and the temperature for H1, we said the first temperature is 180, 60. You can skip through this part of the video. I know it's taking a bit. Okay, 150, 30. I'm just copying the given here. 30, 135, 2, and then the last one is 80, 145. Okay, so what we're going to do is we're going to follow the steps, and we said step one is to subtract delta T minimum from the hot streams, right? In our case, we're given delta T minimum to be equal to 10 degrees Celsius. This one, what I'm going to do, I'm going to subtract it from this stream. So this becomes 170, this becomes 50, this becomes 140, this becomes 20, right? So this is the first step. I'm just subtracting delta T minimum. And then the second step, or step two, will be to arrange the temperatures from the highest to lowest and identify the intervals. So I need to arrange temperatures from highest to lowest and identify the intervals. Okay, so let's do this. So in this case, I'm going to arrange them from highest to lowest. What's the highest temperature here? It is 1. So let's first of all try to draw this table properly. So I have my temperature, and my highest temperature is 170, if you recall the way we're going to do this. Second highest temperature is 140. Third one is 135. 35. Fourth one is 80, 50, 30, 20. And basically the way, I mean, I like to do it is I like to just draw a straight line next to each temperature. This way it's easier to identify the intervals. And it's up to you whichever way you do it, as long as you don't violate the algebra. Feel free to do whatever you want to do, or whatever approach you think works best for you. Okay, and here after defining the highest lowest, I can clearly see that this is interval number 1, right? This is interval number 2 here, 3, 4, 5, 6. So I have 6 intervals. Now let's draw the streams. So I have H1 in this case. It's going from 170 to 50. So 170 all the way to 50. Let's draw this line. H2 goes from 140 to 20. So this is H2. It goes from 140 all the way to 20. I have C1 goes from 30 to 135. So I'm gonna connect 135 to 30. And C2 in this case goes from 80 to 140. So I'm gonna go from 80, actually the other direction, right? I'll do this 80 to 140 right here. Okay, so after doing this, we need to build the interval table, right? So step 3 is actually building the interval table. So here I'm going to do step 3, which is build the, and you can do it on the same one or you can move to a different one, but it's up to you. But what I'm going to do is basically I'm going to just say, I'm going to do it here next to it so that's easier to see. And in this case, I need to tabulate the interval number. I need to tabulate the starting temperature of each interval. I need to tabulate the delta T of each interval. And then I need to calculate this metric, which is summation of Cp hot minus summation of Cp cooled. So let's do it for this case. Let's have a look what's going on here. So here in this case, I have this guy here. This is interval number 1. The initial temperature is 170. The delta T 170 to 140 is 30. Summation of Cp hot minus summation of Cp cooled. I only have one hot stream, and Cp here is 3. So basically it is 3. Then I'm going to do the same. So interval here, interval 2. The initial temperature is 140. The height of this interval is 5. And then summation of Cp hot minus summation of Cp cooled. I have 2 hot streams, 3 and 1. So this will be 3 plus 1 minus summation of Cp cooled. I have 1 cold stream with a C of 5 minus 5. So this is equal to minus 1. Interval 3 here. The initial temperature of interval 3 is 135. The delta T is 135 to 80. That's what, 55. And summation of Cp hot minus summation of Cp cooled. So I have 2 hot streams. 3 plus 1 minus summation of cooled, which is these 2 plus 5. And this is what, minus 3. And again, I'm getting the C's from here. It's usually given. It's always given. Interval 4. In this case, my starting temperature is 80. My final temperature is 50. Summation of Cp hot minus Cp cooled will be 3 plus 1 minus C1, which is 2. So this is 2. For this stream, sorry, for this interval, interval 5, starting temperature 50, delta T is 20. I have 1 hot stream with 1 cold stream with 2. So it's 1 minus 2. It's minus 1. And then my final interval here, number 6. Initial is 30, final is 20. I only have 1 hot stream, right? H2, and it has a CP of 1. So I'm able to tabulate all of them. So I have my interval, my delta T's, my summation of CP hot minus summation of CP cold. And I basically have I calculated the required parameters. Okay, so what's step 4? I need to calculate the internal enthalpies. Okay, this is step 4. So for step 4, I'm gonna rewrite this table, and then I'm going to calculate the delta H by multiplying summation of CP hot minus CP cold by delta T. Okay, so instead of subtracting everything, what I'm gonna do is let's see. If I can just copy this table. Okay, matter. Let's just rewrite it. So step 4 in this case will be just to complete or calculate the internal enthalpies. So let's just recreate this table quickly. So I have interval number. I have I actually have T initial, delta T, summation of CP hot minus summation of CP cold. And then I'm going to calculate delta H, which is equal to summation of CP hot minus summation of CP cold multiplied by delta T. Okay. And let's calculate, or let's basically fill out all these parameters. So in this case, I had interval 1 was 170, 50. This guy was calculated to be 30. 3 by, actually this was 30, right? 30. 3 multiplied by 30 is 90. For interval 2, our initial temperature was 140. Delta T was 5. This was minus summation of CP hot minus CP cold is minus 1. So delta H was minus 5. Number 3, we had 135. We had 55 minus 3, and this is minus 165. 4, 5, 6. I'm just going to fill them. You can double check these numbers. They should be correct. 80, 50, 30. This is 30, 20, 10. This is 2 minus 1, 1. And this is 60 minus 20, 10. Okay, so I have all my delta H's. I have everything. So now I'm going to move to step 4. And if you recall, step 4 is to build the cascade diagram. Okay, and this is very important. This is really where we start doing the important part. Step number 4, build the cascade. Okay, and again, we said in order to build a cascade, you can do it 2 ways. The first way, you can just draw boxes equivalent to the number of intervals. This is really the most straightforward way. So I have 6 intervals. I'm going to draw 6 boxes. 1, 2, 3, 4, 5, 6, right? And then I'm just going to connect them with arrows. Try to be organized when doing it on paper, you know. I'm using this thing. It's very okay. So I build my cascade diagram, and then the cascade diagram has 2 steps. The first step, I'm just translating the data from this table onto this diagram. So let's do this. So I have my initial temperature here. It is, or we can call this T T1, it is 170, and you always write QH equals 0 at the start, and then you delta H, and then you write your delta H's here. So delta H in this case is equal to 90. The second temperature, T2, is equal to 140. Delta H is equal to -5. Yeah, and you just translate your information in the table onto the diagram. T4 is 80, T5 is 50, T6 is equal to 30, and then my final T7 is equal to 20, which is just which is 30 minus the last interval. The final temperature, just that's how you get it. And then I'm just going to write my delta H's here. So I wrote 90, I wrote -5. My third delta H is equal to -165. My fourth delta H is 60. My fifth delta H is -20. And my last delta H is equal to 10. Okay, so this is how you build the cascade diagram, or the initial cascade diagram. And the main activity you want to do here is you want to calculate the Q's, right? So my initial QH is 0. After delta H1, my Q1 here will be equal to 0 plus 90, it's equal to 90. Q2 will be 90 minus 5, it's 85. Q3 will be 85 minus 165, it's minus 85. Or is it minus 85? Minus 80 actually. Q4 will be minus 80 plus 60, so this is minus 20. Q5 in this case will be minus 20 minus 20, so this is minus 40. And your final Q, you can call it Q6, usually you call it QC, will be minus 40 plus 10 minus 30. So this is the first step in building the cascade diagram. And once you do this, we're looking for the lowest heat along the cascade. So I'm looking for the lowest Q. And this will be really step, I think we're jumping steps, but anyways, this will be the next step. Let's, when your homework solutions, I guess it's step 7 now. Anyways, just follow the steps. You can divide them and renumber them whichever way you want, it doesn't matter. But this is the approach basically you need to follow. Okay, let's go to the next step. And we said next step, or let's call it step 6 on this. Step 6, find lowest Q. And where's the lowest Q here? It's this guy, right? It's minus 80. This is my lowest Q. So this is lowest Q. And the point of lowest Q is basically your pinch point. And this is important to remember. Once you find your lowest Q, this is your pinch point. So this is here, pinch point. And this is how you determine the pinch point. Build my cascade. I translate the information from this table onto the cascade, find the lowest Q. And at this point of lowest Q, this is my pinch point right here. Okay? And you can always divide it into a cold pinch and a hot pinch. So this is actually this T cold, this is the cold pinch. This is equal to 80 degrees Celsius. And then the hot pinch is equal to 80 plus delta T minimum. And it's equal to 90 degrees Celsius. Okay? This is how you get to your pinch point, which is the first part of this problem. The second part was asking for the MER targets, or the heat targets. And in order to get the heat targets, I need to add enough heat so that the pinch point, heat at the pinch point is 0, right? And then you need to remember this. So in order to get MER targets, add heat at the top so that Q at pinch is equal to 0. So if my Q at pinch is minus 80, if I add 80 at the top, so if I change this from, if I add 80 here, it's going to cascade down and this will become 0. So if I add 80 at the top here, this will be from 90, it will be 90 plus 80 will be 170, right? 85 plus 80 will be 165. 165 minus 165 will be 0. And then this will be plus 80, this will be 60, this will be 40, and this will be 50. Okay? And then once you add this heat, we're looking for two numbers, QH, which is at the top, and QC at the bottom, and these are your MER targets. So your MER targets in this case will be QH, it's equal to 80, and 80 kilowatts, just remember the units, and QC, which is 50 kilowatts, okay? And this answers your problem. This solves this this type of problem, the algebraic targeting of streams to determine your pinch point, to determine your heat targets, etc. Okay, so this was problem 1. Let's move on to problem 2, and let's do them. I'm going to move quickly now through these problems because the process is tedious, and you can go with it slowly if you want, but I'll just go through it quickly to try and show you the solutions. So problem 2, given the following streams, same idea. I just have a bunch of streams and I need to get delta T minimum. You're given a delta T minimum, you need to get your MER targets and your pinch point. Go to the whiteboard. Let's write the given quickly. So I'm given C1 60, 183, 30, 105, 2.6. So I have C1 60, 183. C2 is 30, 105, 2.6. H1 180, 40, 2. And H2 is 150, 44. Okay. This is the given information, and again, this will be my source temperature at degrees Celsius, of course, target temperature degrees Celsius, and this is my C in kilowatt per degree Celsius, right? So I'm going to follow the steps. First step is remove 10 from the hot streams, and again, just your hot streams, and you need to remove 10. So this will be remove delta T minimum. Be careful as well, don't automatically remove 10 because all the problems are 10. So I'm going to remove delta T minimum. 170, 150, this is 30, this is 30. Second step, I'm going to arrange them from highest to lowest and determine my intervals. So let me just build this table. So in this case, I will have interval. I need to get delta T, or I need to get the initial temperature of the interval. T initial, delta T, summation of Cp hot minus summation of Cp cold, and delta H, which is the multiplication of these two parameters. So let's do this. So again, so I'm going to arrange them from highest to lowest, first of all. And I'm going to get the intervals out of this. So before doing this, let's draw them so that's easier to visualize the intervals, okay? So let's write the temperatures from highest to lowest. So I have 180, and then I'm going to write everyone, and then I'm going to draw a line next to it. 170, then I have 140, right? I have next number is 105, The next one is 60, right? And then I have 30. Okay, so these are the temperatures arranged. So I have, how many intervals do I have? I have 1, 2, 3, 4, 5. I have 5 intervals in this problem. Now let's just draw. Let's draw these streams. So I have C1 going from 60 to 180. So C1 goes from 60. Okay, goes from 60 to 180 at the top here. Okay, struggling now. Okay, there we go. C1, C2 goes from 30 to 105. So C2 goes from 30 all the way to 105. H1 goes from 170 to 30. So this is H1 here. 170 all the way to 30. And H2 goes from 140 to 30. It will go from 140 all the way to 30. Okay, so I defined my 5 intervals, and I'm just going to fill out this table right here. So I'm going to look at interval number 1. My initial temperature in this case is 180. My delta T is 10. Summation of Cp hot minus Cp cold, I only have C1. So it will be 0 minus C1, which is 3. So it's minus 3. And delta H in this case, minus 3 by 10, minus 30. Okay, interval 2. My initial temperature for this interval is 170. Delta T is 30. Summation of Cp hot minus Cp cold. I have 1 hot stream here, H1. So Cp for this guy is 2. 1 cold stream, C1. Cp for this guy is 3. So this is minus 1. Minus 1 multiplied by 30 is minus 30 again. Interval number 3. Initial temperature is 140. Delta T in this case is 35. Summation of Cp hot minus Cp cold. I have 2 hot streams, H1 plus H2. So this is 2 plus 4 minus 1 cold stream, C1, which is 3. And this is 6 minus 3. This is 3. 3 multiplied by 35 is what? 90 plus 15, so it's 105. I have interval 4 here. My initial temperature is 105. My delta T is 105, 60, 45, right? And then summation of Cp hot minus Cp cold, I have the 2 hot streams, which is 2 plus 4 minus the 2 cold streams, which is 3 plus 2.6. This is 6 minus 5.6, so this is what, 0.4? Yeah, this is 0.4. 0.4 multiplied by 45, that's what, 0.4 by 40 is 16, 0.4 by 5 is 2, so this is 18. And then my last stream is my last interval is 5. Initial temperature is 60, delta T in this case is 30. Summation of Cp hot, I have the 2 hot streams here, so it's 2 plus 4 minus the cold stream C2, which is 2.6. 6 minus 2.6, that's what, 3.4. 3.4 multiplied by 30, 90 plus 12, that's what, 102. So I have everything here. I have my intervals, I have my delta H's, everything. I translated this table to my interval table, and now the time comes to build the cascade diagram. Okay, so build the cascade again. I'm just going to draw 5 boxes equivalent to my intervals. So I have equivalent delta H's really, and the intervals the same way to think about it. So I have 5, so I'm going to draw 5 boxes. This is what, 3, 4, 5. Here we go. And then I'm just going to connect these arrows. And on paper, you can be more organized. You can do it in Excel if you want to be very fancy. Anyways, and then I'm gonna basically put all this information I have in this table onto here. So my initial temperature in this case is 180, and then it's 170. So T Let's call them TI. You can call them T1, T2, doesn't matter. 140, 105, 60, and then the last one is 60 minus delta T. So this is 30. And then I'm just going to write the delta H's here. So delta H minus 30 minus 30, 105, delta H 18, delta H is 102. And then the first step, I'm going to start QH is equal to 0, and I'm going to determine the pinch point by just calculating the Q at every interval. QH minus 30, so Q1 in this case is minus 30, Q2 minus 30 is minus 60, Q3 minus 60 plus 105 is 45, Q4 45 plus 18, so it's 63, and then QC at the very bottom, 63 plus 102 is what, 165. And then I'm going to look at the lowest Q, and in this case, the lowest Q is this guy right here, right? Lowest Q, so this is my pinch point. So this is the pinch point. So from this case, from here, I can deduce that T pinch is equal to 140 degrees Celsius. Okay, so in order this, I get the pinch point, and then in order to determine the MERs, I need to add heat in order for this point to be 0. So I'm going to add 60, so I'm going to plus 60, and then I'm just going to add 60 is just going to cascade down and be added to every one of these. So this plus 60 is equal to 30, plus 60 here is equal to 0, which is what we want. We want to add enough heat so that the heat at the pinch is 0. Plus 60 here is 105, plus 60 here is 123, right? And plus 60 here is equal to 225, okay? And then I'm going to take the top number and the bottom number, and these are the MER requirements. So MERs in this case, QH is equal to 60 kilowatts, QC is equal to 225 kilowatts, okay? And this is how you work through this problem. And for problem number 2, this is the solution. Okay, good. Now let's have a look at problem number 3 in this homework, or actually, am I sharing the solutions? No, we want to look at problem number 3. Okay, let's have a look here. Problem number 3, you're given a lot of streams now, and the same thing is going to apply. It's just an exercise in, you know, mentally managing a whole, like a lot more streams. Okay, so let's work through it. It should be fine. It's not really a big deal. You follow the steps, you'll get the answer, right? There's really nothing to it more than following the steps, trying to be efficient, trying to you know, iron out the algebra, try not to be sloppy when solving these problems, because, you know, you're going to end up making a lot of basic errors, which will screw all your design, especially when you use these numbers later to design a heat exchange network or design something else. Okay, so I'm doing problem number 3 in this case. There we go. Problem number 3, and here I have T source, T target. I'm just going to write the given and C in kilowatt degree Celsius, and I have C1, C2, C3, H1, H2, H3, and I'll just write the given 100, 180, 200, 440, 520, 390. I have 430, 350, 400, 150, 300, 150. And here I'm given a bunch of weird numbers. 2.6, 2.8, 2.38. Okay, so first step, as always, I'm going to subtract the 10, or what's the delta T minimum in this problem? Delta T minimum is 10, so I'm going to subtract the delta T minimum from the hot streams. So in this case, my delta T minimum will be, or the new temperatures, adjusted temperatures will be 430, 140, 290, 140, 380, 510. Okay. After doing this, next step will be to arrange them in order to determine how many intervals I have and start building this interval table in this case. So let's arrange these temperatures from highest to lowest. And again, we have a lot of temperatures here, so just try to be organized with your work. Highest temperature is 510. And I like to just draw a line. Then it's 430. Right, then it is 400, 380, 350, 290, 200, 180, 140, and 100. Okay, so these are my streams, and then I'm gonna just plot, or these are my intervals. Sorry, so how many intervals do I have actually? Let's just count them now. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 intervals in this case. Let's just plot these streams. As you can see, the process is the same. It's just the algebra now is a bit more tedious, but that's how it is with these types of problems when designing these systems. Of course, if you can program it into Aspen, that will make things much quicker. But you also need to be able to troubleshoot it and what's going on. Okay. Anyways, so I have C1 from 100 to 430. So I have from 430 all the way down to 100. Right, so this will be C1. C2 is 180 to 350. So I have 350 all the way down to 180. This is C2. C3 is 200 to 400. So I have 400 all the way down to 200. H1 in this case is 430 to 140. 430 to 140. H2 is 510 to 290. Right, so I have 510. Oops. All the way to 290. And H3 in this case is 380 to 140. So I go 380 all the way down to 140. Good. So I basically drew this thing. Now let's build our interval table. If you recall, I'm just going to translate this into a table with numbers, so it's easier for me to look at it. So I have interval. I have my T initial. I have my delta T. I have summation of Cp hot minus summation of Cp cold. And then I have my delta H right here. Let's fill out this table slowly. So interval 1, my initial temperature is 510. My delta T is 430 to 510 is what? 80. Summation of Cp hot minus Cp cold, I only have H2, which is 2.38. And then delta H, if you multiply these two numbers, you should get 19.4. Similarly, interval 2, initial temperature is 430, delta T is 30, Summation delta H minus summation of CP hot minus CP cold is H1 plus H2. The summation of CP hot. So H1 I have 2.8, H2 I have 2.38 minus CP cold, which is C1 1.6, and this will be equal to the number I have is 3.58, and if I multiply 3.58 by 30, I get 107.4. Interval 3, and again 400 to 380, so the initial temperature is 400. The delta T in this case is 20. Summation of CP hot minus CP cold in this interval, I have two hot streams, H1 and H2. So H1 plus H2, so I have 2.8, sorry, this is close right here, plus 2.38 minus my cold streams, just C1 and C3, so 1.6 plus 2.6 minus 1.6 plus 2.6, and this will be equal to 0.98, and the delta H for this guy will be 0.98 by 20, and this is 19.6. Okay, let me just just be aware. Okay, now let's move on to interval number 4. Initial temperature is 380, delta T is 30. You do summation of CP hot minus CP cold, you're gonna get 4.34. And again, just slowly look at them, hot streams, add them, cold streams, subtract them, etc. You're gonna get your numbers. And delta H in this case is 130.2. And we're just going to write the numbers for the rest of them. They're shown in your solutions, so you can always have a look and see how we got them. 290, 200, 180, 145, 6, 7, 8, 9, and delta H's for these guys are 60, 90, 20, 40, 40. Summation of CP hot minus CP cold is 1.07 minus 1.31, 1.29, 4.56 minus 1.6, and delta H's I got is 64.2 minus 117.9. If you don't see where any of these numbers are coming from, send me an email, come to office hours, we'll work through them. Okay, anyways, so I have all of this information. I have my interval table here. It's nice. Okay, I have everything I need to build a cascade diagram. So let's go ahead and build our cascade diagram. So I'm going to draw it on this side because I have enough space. Again, it's the same exact process. You just have to be organized, have to be careful with what you're drawing, what you're doing, all of this stuff. Okay, let's draw it in red. So I have 9 intervals, so I'm going to draw 9 boxes. So I have my first box here, 2, 3, 4, 6, 7, 8, 9. Okay, and then I'm just going to connect the arrows for filling them with the information. And it can be tedious, but this is part of the job. Okay. Okay, and then first thing, I'm going to just write the initial temperatures of each interval. So the initial here is 510. I'm basically copying this table onto this figure, right? If you're having a hard time seeing this, just let me know. The initial here is 430. T initial here is 400, 380, then 350. This guy is 290. This guy is 200. This guy is 180. This guy here is 140, and then the final temperature is 140 minus 40. So this guy is 100. Okay. Next step, I'm going to write the delta H's inside these boxes. So delta H here is 190.4. Delta H here is 107.4. Delta H here is 19.6. Delta H here is 130.2. In this case is 64.2. Delta H here is minus 117.9. Again, a common error, especially if you're just copying the numbers one by one, is to just jump one, right? This is, you know, from last year, this seemed to be, especially on an exam where you want to finish things quickly, this seemed to be, or copying a number twice, you know, just very small, minor things you have to keep an eye out for. Okay, anyways, so we added all this, and then we're going to calculate the Q's. So first of all, QH here at the top is going to be 0. I'm going to start calculating the Q at each interval. Q1 will be 0 plus 190.4, so it's equal to 190.4. Q2, 190.4 plus 107.4 will be 297.8. Q3 is 297.8 plus 19.6, 317.4. Q4 here, again, same idea, this guy plus this guy. We're going to get 447.6. Q5, 447.6 plus 64.2 is 511.8. Q6 will be this plus this, and this is 117.9. Is going to be equal to 393.9. Q7, 393.9 plus 25.8 will be 419.7. Q8, 419.7 plus 182 will be 602.1. And the final Q here, QC, will be 538.1. Okay. So this is an interesting problem here. None of the Q's are negative. You know, I don't have any negative Q's. Okay. This might happen, right? So first of all, let's find the lowest Q, right? This will be my my pinch point. So if I look here, my lowest Q is actually here at the top, QH equals 0. So this is my pinch point. And this is a special type of problem where the entire plant or the entire system is below the pinch, right? And this is typical. You might see it in highly exothermic processes or in highly exothermic systems where I don't need any heating requirements. I just need cooling requirements, right? My entire system is below the pinch. So in this case, my T pinch will be 510 degrees Celsius, and my MER targets will be QH will be 0 kilowatts. I don't need any heating for the system. Everything is below the pinch. However, I need a lot of cooling for the system. QC will be equal to 538.1 kilowatts, right? So this is this answer to problem number 3. Again, it's a special type of problem where your entire system is below the pinch. It's not unusual to have these systems, and this is how you manage these types of problems. Okay, good. Let's clear out all this. Let's go back to problem number 4 now. Problem number 4. Given the following streams, same idea. Delta T minimum equals 30. Determine the MER targets and the pinch points. Let's do it. Same process. We'll just go through it slowly, and we will get the solutions. Okay, first of all, let me write down the stream information. So I'm doing problem number 3. So again, let's write T source in degrees Celsius, T target in degrees Celsius, and C in kilowatt per degree Celsius. And I have H1, this guy, I have H2, actually C1, or is it H3? H3, and C1, and the temperatures here are 525, I'm just copying the table, 500, 475, 275, and in this case it's 300, 375, 300 again, 500, and these numbers 2, 4, 3, 6. Okay, first step, we're going to subtract the delta T minimum from my hot streams. Where the delta T minimum in this case 30, so I'm going to subtract 30 from the hot streams. 495, 270, 345, 270, 445, and was what? 470. Great. Good. So I did this, subtracted the hot temperatures. So now I'm going to arrange the temperatures from highest to lowest and plot my streams. So from highest to lowest, I'm going to get 500, 495, 470, 445, 345, 275, and 270. And again, be careful here. A very common error as well is to just skip one of the numbers, because sometimes it's hard to arrange these from highest to lowest when you're looking at the table. So I highly recommend you maybe use a scratch paper, put them in a list and scratch them out so that you don't make this mistake. Anyways, let's plot these guys. So I have H1 from 495 to 270. 495, oops. 495 to 270 here. And this is H1. H2 is from 470 to 345. 470 to 345. H3 is from 445 to 270. All the way to 270. And C1 is from 275 to 500. So the C1 has the highest or the biggest delta T. It's fine. Okay, so we have this. Now let's translate it into an interval table. So let's do this. So again, in our interval table, so again, how many intervals do we have here? First of all, 1, 2, 3, 4, 5. I have 6 intervals. Okay. So interval, T initial, delta T, summation of Cp hot minus summation of Cp cold, and the last metric will be delta H. So let's do this. So interval number 1 here, T initial is 500, delta T is 5, summation of Cp hot minus Cp, only have one cold stream. This is minus 6, and this is minus 30. Interval 2, I start at 495, I end at 470, so this is 25. Cp hot, I have one hot stream, which is 2. Cp cold, I have one cold stream, which is 6. 2 minus 6 is minus 4. So in this case, it's minus 100. Interval 3, my initial temperature is 470. My delta T is 470 is 445, that's what, 25 again. And I have 2 hot streams, H1 plus H2, 2 plus 4. One cold stream, C1, 6. 2 plus 4 minus 6. This is 0. Delta H here is 0. Okay. Interval 4, my initial temperature is 445. My final temperature, so delta T here is 100 actually. And if I have a look, the summation of Cp hot minus summation of Cp cold. I have all the streams, so I have all hot streams minus the single cold stream. So in this case, 2 plus 4 plus 3 minus 6, so it's going to be equal to 3. And delta H in this case is 300. interval 5, my starting point is 345, right? And my ending point, 345 from 275 is what, 70? Summation of CP hot minus summation of CP cold. I have H1 and H3, and I have C1. So H1 plus H3 is 5, minus C1 minus 6 is minus 1. And delta H is minus 1 multiplied by 70 minus 70. And then finally 6 here. My initial temperature is 275. My delta T is 5. Summation of CP hot minus CP cold. I only have two hot streams, H1 and H3. So this is equal to 5. And 5 multiplied by 5 is 25. Okay, so now I have my interval table. I need to translate it onto a cascade diagram. So let's do this. Again, in order to do this, first step, I'm going to draw 6 boxes equal to the 6 intervals. So I have 6 intervals, so I'll just draw 6 boxes. 1, 2, 3, 4, 5, 6, and then just connect the arrows here. Okay, and then I'll just put all this, translate this information from here onto this figure. So let me just start by the temperature. So this interval here, the interval is 500. For this guy, it's 495. This guy right here is 470. Is it? Yeah, 490, 470. This guy is 445. 345. 275, and the last one here is 275 minus 5, which is 270. Okay, and then next step, I'm going to write the delta H's. So delta H here, minus 30. Delta H here is minus 100. Delta H here is 0. Delta H here is 300. Minus 70. And 25. And then finally, I'm going to add the heats. So QH initially is 0. QH minus 30, so Q1 is minus 30. Q1 minus 100. Q2 is minus 130. Q3 is minus, or yeah, Q3 is minus 130 again, minus 130, 0, minus 130. Minus 130 plus 300 is what? 270? Is it 270? 170. Q5, 170 minus 70 is 100, right? And then finally 100 plus 25, QC at the bottom is 120. Okay. So now when we want to determine the pinch point, I'm looking for the most negative Q. And if I look at this cascade figure right here, I have an interesting thing going on. I have two most negative Qs, right? So my most negative Q is actually minus 130. It's also minus 130 here. So which one is the pinch? Your pinch point will be the lower temperature. This is how you decide these cases, okay? So in this case, because I have minus 130 at 2 points, at 2 intervals, my pinch point in this case will be 445 degrees Celsius. You always pick the lower temperature, okay? So now I'm gonna add enough heat for this to be 0. So I'm gonna add 130 basically. So this will be equal to no, so we need to add enough heat so that the Q at the pinch is 0, right? So you have to be careful what we're gonna do here. So in this case, I can add 130 and have this be equal to 0, but then this will be minus 130, right? So just be careful. The solution in your the solution posted might not be, it's not really the most optimum solution. What I recommend you do is, let's add 260. Let's have a look what happens if we add 260. So this will be 260, this will be 230, this will be 130, this will be 0, right? This will be now 260 plus 170 is how much? 430. Where's the mouse here? 430, 260 plus 100 is 360, and 260 plus 125 will be 385, okay? So in the solution posted, just be careful, there's a small error because I just added 130, like disregarding that I have two minus 130s. You need to add enough heat so that the Q at the pinch is equal to 0. And in this case, we have to add 260 for the Q at the pinch to be equal to 0. If I add only 130, then I'm fixing the Q pinch to be at 470, which you can do it. You can always design a system at this higher end pinch point. However, you're always better off designing a system at a lower pinch point because this will save you more energy. You know, thermodynamically, it will save you more heat. So in this case, this solution, so if you're going to add 130, make sure to mention the pinch as 470. If you're going to add 260, then your pinch point is 245. So in this case, I set the pinch at 245. So I added 260 so that the Q at the pinch is 0. And for 445, the QH will be 260 kilowatts, and the QC will be equal to 385 kilowatts, okay? And this is the solution for problem number 4. Again, same procedure, just follow the steps, try to go through the process, and you'll always get the same, you always reach a solution or reach the pinch point and the heat targets, okay? And then final problem number 5. Let's do problem number 5 as well. Just want to make sure I didn't. Okay, and this problem is unique in the sense because I have 5 hot streams and 1 cold stream. It's a very special type of process. And you know, algebraically, when designing the heat exchange network, it's a unique system. But for our case, let's just draw the. Let's just write that down the streams. So in this case, oops. Okay. Problem 5, and I'm just going to write the stream T source, T target, and C. And again, this is in degrees Celsius. This is in degrees Celsius. This is in kilowatts per degree Celsius. And I have H1, H2, H3, H4, H5, and C1. And let's write the temperatures here: 500, 480, 460, 380, 380, 290, and the target temperatures here: 320, 380, 360, 360 again, 320, and 670. And the C here is 6, 4, 6, 20, 12, 18. Okay. So again, first step, I'm going to subtract the delta T minimum from all the hot streams. And in this case, delta T minimum is equal to 10 degrees Celsius, right? So if I subtract it from all these streams, so I get 490, 310, 290, 350, 350, 310, these two are 370, this guy here is 450, and this guy is 470. Good, and now I'm gonna arrange the temperatures from highest to lowest for next step and try to plot these streams. Okay, let's see. Let me just, before doing this, let me just write these temperatures on the side here, so it's easier for me to cancel them out. Okay, so I have 490, 470, 470, or actually 490, 470. I have a 450 here. Then I have a 370. I have a 350. I have a 310. I have a 290. And I have a 670 here, right? So I have 490, 470, 450, right? 670 at the top. I have a 370, a 350, a 310, and a 290. Did we miss any numbers? No, I think we have all the numbers here. It's good. So now let's plot them and see how the system is looking. So again, I'm just going to write them here. 670, 490, 470, 450, 370, 350, 310, and 290. And how many intervals do we have? You can see that I have 1, 2, 3, 4, 5, 6, 7. So I have 7 intervals. So let's just plot these streams. So each one goes from 490 to 310. Oops, 490 to 310. This is H1, H2 from 470 to 290. 470 all the way to 290. H3 goes from 450 to 350. 450 to 350. This is H3. C1, or actually I still have H4, right? They're all H's. H4 goes from 370 to 350. 370 to 350, this is H4. H5 goes from 370 to 310. 370 all the way to 310, this is H5, and then finally C1. I have C1 here going from 670 to 290. This covers the entire range. Boom, here, C1. Good, so I have everything. Now let's try to translate this into an interval table right here. So let's try to write let's write the interval table. So I have interval number, right? My T initial, my delta T, summation of CP hot minus summation of CP cold, and I have my delta H here at the end. Let's write this interval 1. Initial temperature is 670, delta T 670 to 490. That's what 180, right? I have 10, and then I have 170, 180. Summation of CP hot minus CP cold. Just verify this, yeah. I only have one cold stream here, which is C1, so this will be minus 18. And delta H will be minus 18 multiplied by 180. And this is minus 3240. Minus 3240. Good, interval 2. I'm going from 490 to 470, so my initial temperature is 490. My delta T is 20. Summation of CP hot minus CP cold, I have H1 minus C1. So I have 6 minus 18. 6 minus 18 is with minus 12, and delta H will be minus 12 by 20. And this is minus 240. Interval 3, my initial temperature in this case is 470. My delta T again is 20. My summation of CP hot is H1 plus H2, so it's 6 plus 4, minus summation of CP cold is 1, which is minus 18. And in this case, it's 10 minus 18 minus 8, and minus 8 by 20 is minus 160. Interval 4 starts at 450, ends at 370, so the delta T here is 80. Summation of CP hot, I have H1, H2, H3. CP equal to C1. So H1 is 6 plus H2 is 4 plus H3 is 6. CP equals minus 18, so with 10 plus 6, 16 minus 18 minus 2. Minus 2 by 80 is minus 160. Interval 5 is this guy, starts at 370, ends at 350, so delta T is 20. And it has all the delta, it has all the streams, right? So summation of CP hot will be all of these guys. 6 plus 4 plus 6 plus 20 plus 12 is how much? 6 plus 4 plus 6 plus 20 plus 12, this is 48, minus C, which is 18. So this is 30, 30 by 20 is how much? 600, okay, good. Interval 6 in this case starts at 350, ends at 310, so delta T is 40. So in this case, I have H1, H2, and H5. So H1 is 6, plus H2 is 4, plus H5 is 12, right? Minus 18, this is how much? 6 plus 4 plus 12, minus 18, this is 4. And 4 by 40 is 160. And then finally, the last interval, interval 7, starts at 310, ends at 290, starts at 310, ends at 290, so delta T is 20. My H2 in this case is 4, and my C1 is minus 18, so 4 minus 18 is minus 14, and minus 14 by 20 is 280, or minus 280. So I have all my intervals here, I have all my delta H's, and now let's try to translate this onto a cascade diagram. Just verify that these calculations are correct, just don't copy them. I might have made a calculation error, hopefully not, but yeah, just verify that. Okay, so now let's translate these into a cascade diagram. So in order to do this, I'm just going to erase these numbers from this side. And I'm going to draw my cascade diagram. And again, first thing, let's just draw the boxes equivalent to the intervals. So I have 7 boxes, I have 7 intervals, 7 intervals, 7 boxes. 1, 2, 3, 4, right, 4, 5, 6, 7. Just connect them with the arrows here. Are these 7? 1, 2, 3, 4. Okay. And let's add the initial temperatures onto these guys. So I have Ti, the initial temperature of each interval, Ti 670, Ti 490. Again, I'm just translating this table onto the diagram. Ti equals 470, Ti equals 450, Ti equals 370, Ti equals 350, Ti equals 310, and then the final Ti here is equal to 290, which is 310 minus 20. Okay, and then I'm gonna write the delta H's here. So delta H minus 3 to 40. Delta H here is minus 240. Delta H here is minus 160. Delta H here is minus 160. Delta H here is 600. Delta H here is 160. And delta H here is minus 280. So I have all my delta H's. Now let's add up the Q's for the heats. So we start off by QH here is equal to 0. And 0 minus 3240 is minus 3240. Minus 3240 minus 240 is what? 3480. So this is minus 3480. Minus 3480 minus 160. Minus 3640. Minus 3640 minus 160 again. Minus 3800. Minus 3800 plus 600 is minus 3200. Minus 3200 plus 160 is minus 3040. And finally QC here, minus 3040 minus 280 is minus 3320. Okay, so now I need to find my pinch point. My pinch point is the most negative point. So in this case, Q4 here, this is my pinch point. So in this case, this is my pinch point, and T pinch is equal to 370 degrees Celsius. And then I'm going to add enough heat for the pinch point to be 0. So plus 3800, this is equal to 3800. Plus 3800, this number here is equal to 560, right? Plus 3800, this number becomes 320. Plus 3800, this number becomes 160, right? Plus 3800, this is 0, my pinch point. This is 600. This is 760. And then finally plus 3800. This is equal to 480. And I need this number and this number here. So my MER targets in this case is QH is equal to 3800 kilowatts and QC is equal to 480 kilowatts. And this is the answer to problem number 5. And this concludes the homework. If you're not clear on anything, please come to office hours. And please don't hesitate to reach out by email or, just ask me, and we'll work through this. It's a very important skill. It's a very important process to know for this course. It will show up on your exam, and it will be a big chunk of your exam, if not all of it. Okay, thank you very much.